Well, hello there. You've joined us again for another deep dive. Today, we're going to be focusing on a particularly ambitious mission. A very ambitious mission, I think you'll agree. Gemini 11.
Yes, ambitious is certainly one word for it.
We thought we'd delve into it a little deeper and present some information. Hopefully, you'll find it interesting.
As always, Project Gemini, well, you'll likely recall that it was really the bridge between the Mercury flights,
Yes.
the very early days,
Yeah,
and the grand aspirations of Apollo.
absolutely.
And it was within this program that many of the techniques needed for lunar missions were perfected.
Right.
And Gemini 11 holds a very important place in this story.
Yes, and we're going to find out why. This wasn't just another flight. I mean, Gemini 11 really pushed the boundaries of what was possible.
It did.
We're going to be unpacking the principal objectives.
Yes.
And the achievements, the quite remarkable achievements, really, of Gemini 11.
Indeed.
And we're going to be looking at some genuine firsts.
And some very ambitious aims.
Yes, it was.
Now, we've, to give you a really solid exploration of this, we've consulted a variety of notes, briefing documents, and study guides, haven't we?
We have.
And our focus is going to be very much on the flights themselves, the goals, the outcomes,
Of course.
the timeline of the entire mission.
Indeed.
So our mission today, if you like, is to extract the most fascinating and insightful details surrounding Gemini 11's flights.
Yes.
And the experiments. Let's get straight into it. One of the really standout objectives was the first orbit rendezvous.
Yes. Well, this was the thing. They wanted to achieve a direct ascent rendezvous with the Agena target vehicle on that very first orbit. And the main objective behind this was for the Apollo program.
Yes, of course.
To create as realistic a simulation as possible of the lunar module's rendezvous with the command service module.
Right. So a very quick dress rehearsal in Earth orbit.
Exactly.
For a very important maneuver on the moon. Yes, and they had to get this launch trajectory absolutely precise for this to work.
Yeah. And how quickly did they manage to make that link up?
Well, astonishingly quickly. They achieved rendezvous and docking with the Agena, approximately 94 minutes after launch.
94 minutes?
Yes.
Gosh, that's incredibly fast.
It is. 16.16.00 coordinated universal time.
Goodness me. And that wasn't just a case of ground control guiding them every step of the way, was it?
No. Very much. They relied heavily on the onboard computer and radar.
Right.
And ground support played a very minimal role.
So this really was a demonstration of their own navigational capabilities.
It was, yes.
That must have been a lot of calculations to do in a very short space of time.
Absolutely.
Now, even the mission patch alludes to this.
It does.
Yes.
If you look at the Gemini 11 mission patch, you'll see a small gold star.
Yeah.
Above the Earth and to the left. And that star commemorates the first orbit rendezvous with the Agena.
Right. So it's a subtle but important recognition of what they achieved.
Yes.
So now after that incredibly fast link up, they weren't slowing down, were they?
No, they weren't.
Because they had their sights set on a much higher altitude, didn't they?
Yes, a very ambitious altitude. The next objective was to use the Agena rocket engine to propel the combined Gemini and Agena into a high apogee elliptical orbit.
Okay. So what sort of altitudes are we talking here?
Well, they achieved an apogee of 1,374 kilometers, or 854 miles.
Goodness me, that's quite some way up.
It is, and the perigee was much lower.
Yeah.
At 298 kilometers, 185 miles.
Right.
So this was a very highly elliptical orbit.
Right, so they were really going up into the upper atmosphere there.
They were.
And this set a record, didn't it, at the time?
It did. It was the highest Earth orbit ever achieved by a crewed spacecraft.
And that record stood for quite some time.
It did, until the Polaris Dawn mission in 2024.
Right.
Of course, the Apollo missions went much further.
Yes.
But those were on a trajectory towards the moon. They weren't orbiting the Earth.
No, of course. So just in terms of orbiting our own planet, they held that record for a very long time.
Yes, they did.
It puts into perspective, doesn't it? Even the space shuttle.
It does.
The altitudes of the space shuttle, ventures like Inspiration 4, it makes them look quite low.
It does. The shuttle's operational altitude peaked at about 621 kilometers for the STS-31 mission.
Right.
And the Inspiration 4 flight reached 585 kilometers.
Okay, so quite a difference.
Yes, considerable.
And this was all thanks to the Aegina's engine firing after they docked.
Yes. Once they were securely docked, they used the Aegina rocket motor to perform this maneuver.
Right. But they didn't stay in this extreme orbit for the whole mission, did they?
They didn't, no. They then went back down to a near circular orbit of about 296 kilometers, 184 miles.
Right, okay. And this achievement, the high altitude, is also commemorated on the mission patch.
It is. If you look at the very top of the Gemini 11 mission patch, there's another star.
Right.
That signifies the record high apogee.
Okay. Gosh, so much information in these patches. Now, this high Earth orbit, there's an interesting backstory to that, isn't there? Something to do with potential lunar missions for Gemini.
There is. There were these earlier, quite ambitious proposals to use the Gemini spacecraft for lunar missions.
A lunar mission using Gemini.
Yes. Pete Conrad was a big advocate of what was called Gemini Large Earth Orbit. And the idea was that that Gemini 11, could potentially undertake a circumlunar flight.
A circumlunar flight using Gemini. Wow, that's very ambitious.
It was. The proposal was to launch the Gemini crew on a Titan II GLV, as they did, and then have them dock with a Transstage booster.
Okay.
Launched separately on a more powerful Titan II.
Right. And
this Transstage is an upper stage designed for orbital transfers.
Yeah.
That would then have the thrust for translunar injection.
So they were really thinking about skipping ahead of Apollo for this circumlunar mission with Gemini.
Well, Conrad did manage to get some interest in Congress.
Okay.
However, in the end, NASA Administrator James Webb decided to prioritize and accelerate the Apollo program.
Right.
And he felt that any additional funding would be better spent on achieving that lunar landing.
Okay.
So the circumlunar Gemini never got off the drawing board.
Right. It remained a what if. But the high apogee flight of Gemini 11, that was a direct result of these ambitions.
Yes, it was. That high apogee that Gemini 11 reached, that 3,370 kilometer mark, is considered to be the only tangible outcome.
Right.
Really the only vestige of these earlier expansive lunar Gemini plans.
Fascinating to think what might have been. Now, moving on from all the orbital maneuvers, Gemini 11 also featured 2 EVAs, didn't it?
It did, yes.
Extravehicular activities.
Yes.
For Richard Gordon.
For Dick Gordon, yes.
And the first of those, the first EVA, was aimed at quite a specific task, wasn't it?
It was, yes. The objective was to fasten a 100-foot tether between the Gemini spacecraft and the Aegina target vehicle.
Right.
This tether, it was stowed within the Aegina's docking collar.
Right.
And it was to be connected to Gemini's docking bar.
Okay, and this was all for an experiment they had planned later on.
That was, yes, for this passive stabilization experiment.
Yes.
And the artificial gravity.
Okay.
Richard Gordon began this first EVA on the 13th of September, 1966.
Yeah.
At 14.4400 Coordinated Universal Time.
But it didn't go quite as planned, did it?
It didn't.
I remember reading that it was a lot more tiring than they'd expected.
It was. They did a lot of simulations on the ground.
Yes.
But Gordon found it much more fatiguing in space.
Right.
So the EVA had to be terminated early.
Oh, dear.
After only 33 minutes. So it ended at 15.1C1000 UTC. Much shorter than the planned 2-hour duration.
Oh, so they didn't quite manage to complete the task.
They didn't. They encountered difficulties.
Right.
But it provided very useful information for future spacewalks.
Yeah, of course. And this first spacewalk, it's marked on the mission patch as well, isn't it?
It is, yes. If you look on the right-hand side of the Gemini 11 mission patch, there's another star there.
Right.
To commemorate Dick Gordon's spacewalk.
So each of these 4 stars tell a very particular story, don't they?
Yes, they do.
Right. Okay. Now, Gordon also undertook a second EVA, but this was very different.
It was. The second EVA, which took place on the 14th of September, 1966, began at 12.49.0000 UTC. This one was a stand-up EVA.
A stand-up EVA.
So Gordon didn't fully leave the spacecraft.
Oh.
He just had his head and shoulders poking out the hatch.
Right. So much less physically demanding then.
Yes, much less so.
Right.
And the main objective was for Gordon to take photos of the Earth, cloud formations, and the stars.
Right.
And this proved to be much less tiring for him. It allowed for quite sustained observations.
Yeah.
Without the rigors of a full spacewalk.
Good. And he had quite a while to do this, didn't he?
He did, yes.
Yeah.
The second EVA lasted 2 hours and 8 minutes.
Okay.
And it ended at 14.57.00 UTC. And by all accounts, this was a very successful period of photographic reconnaissance.
Excellent. So the two EVAs provided very contrasting experiences for Gordon.
They did.
In terms of the workload and the outcome.
Absolutely.
But they both gave them valuable insight, didn't they, into the challenges of working outside of the spacecraft.
They did.
Right. Now let's talk about that tether experiment.
Okay.
Because the aim was passive stabilization and artificial gravity, wasn't it?
It was, yes.
Yeah.
So this 100-foot tether that Gordon attached was central to this experiment.
Right.
The idea was that once the Gemini and Agena separated in a nose-down configuration with the Agena pointing towards Earth,
right,
the Earth's gravity gradient would naturally keep the tether taut.
Yeah.
And gravity gradient refers to the slight difference in gravitational pull between two objects at different distances from a celestial body.
Right. Gotcha.
And so this tension would provide passive attitude stabilization for the linked spacecraft.
But it didn't work, did it?
It didn't. Yeah. Despite their efforts, Conrad and Gordon just couldn't get this tether to stay taut.
Right.
Just using the gravity gradient alone. Mm-hmm. So the passive stabilization aspect of the experiment failed.
Oh, dear. A bit of a setback.
It was.
But they did manage to generate some artificial gravity using a different method.
They did, yes.
Yeah.
Although that passive stabilization failed.
Yeah.
They did achieve a small but measurable amount of artificial gravity, about 0.000015 grams.
Okay.
And they did this by firing their side thrusters in a very controlled manner.
Right.
To slowly rotate the combined tethered spacecraft.
Okay.
And this created a very gentle centrifugal force.
I see.
So it's a bit like a slowly rotating pair of weights.
Right.
Joined by a string.
Okay, so a very clever way of still achieving their aim.
Yes.
Albeit in a slightly different way.
It was, yes.
It shows their adaptability, doesn't it?
It does, yeah.
The crews, mission control, everyone. Now, aside from all these headline-grabbing events, Gemini 11 also carried a whole suite of scientific experiments, didn't it?
It did, yes. There were 12 in all.
12.
Right.
Hey, could you give us a couple of examples?
Well, one was the mass determination experiment. And this aimed to test a direct contact method of accurately measuring the mass of an orbiting object.
Okay.
Which in this case was the Agena target vehicle.
Right.
Another one was the synoptic terrain photography, where the objective was to obtain high-resolution photographs of the Earth's surface for research in things like geology and oceanography.
So that sort of ties in with Gordon's EVA photography?
It does, yes.
Isn't it?
Very much so.
Yeah, okay.
And then there was synoptic weather photography.
Right.
Which is all about getting detailed pictures of cloud structures to aid in the study of Earth's weather systems.
Right. Goodness me.
There were experiments looking at the effects of radiation.
Yes.
And the zero-gravity environment on biological samples.
Of course, yeah.
There were investigations into ultraviolet astronomy.
Wow.
And they even tried to photograph the Earth-Moon libration regions.
Really?
In search of the hypothetical Kordylewski clouds.
Gosh, so a whole range of
of
science being done during this mission. Now, as the mission came to a close, they also tested a very important technological development, didn't they?
They did.
During re-entry.
Yes. Gemini 11 marked the first time the U.S. performed a completely automatic computer-controlled re-entry.
How accurate was this?
Well, very accurate. Mm-hmm. The Gemini 11 spacecraft splashed down just 2.8 miles from the recovery ship, the USS Guam. That's just 1.5 miles from the planned position.
Wow.
So very accurate indeed.
That's impressive. So we've mentioned the crew a few times, but let's formally acknowledge them.
Well, we had command pilot Charles P. Conrad Jr.
Yeah.
This was his second space flight.
Yeah.
And pilot Richard F. Gordon Jr.
Yeah.
And this was his first space flight.
Right. And then, of course, there was the backup crew.
Yes.
And all the people on the ground, all the support staff.
Absolutely.
Yeah.
So backup crew, we had Neil A. Armstrong as command pilot and William A. Anders as pilot. Mm-hmm. And on the ground, we had Clifton C. Williams Jr.,
yeah,
John W. Young, mm-hmm. Alan L. Bean, all serving as capsule communicators.
Yes.
Or Capcoms.
The mission patch. Mm-hmm. We've talked about the mission patch quite a bit, but could you perhaps just sum up the significance of the colors?
Well,
and those stars again?
Both Conrad and Gordon came from the U.S. Navy.
Right.
So the mission badge was designed using the Navy's colors, blue and gold.
Okay.
And then the stars, well, we've kind of gone through them.
Yeah.
But to summarize, a small gold star above the Earth to the left signifies the first orbit Agena rendezvous.
Right.
A larger star on the left commemorates the Agena docking.
Yeah.
The star at the very top marks the record high apogee. And finally, the star on the right acknowledges Dick Gordon's spacewalk.
A really nice summary there on the patch. And for anyone who's really interested in this mission, is there anywhere they can go to actually see something from the mission?
Well, the actual Gemini 11 capsule is on display at the California Science Center.
Right.
In Los Angeles.
Fantastic. So if you're ever in that neck of the woods, you can go and see it.
Yeah.
Finally, a mission of this complexity must have needed a huge support network.
Huge, yes. A very large logistical effort.
Yes.
It involved 9,054 personnel from the Department of Defense, 73 aircraft, and 13 ships.
Gosh, a real team effort.
It was.
Right. Well, we're coming to the end now of our deep dive into Gemini 11. What would you say were the biggest achievements of the mission?
Well, I would say those most notable achievements were, firstly, the first direct descent rendezvous achieved in a single orbit. Secondly, that record-breaking high Earth orbit, which stood for so long. And then just the sheer breadth of the scientific experimentation that they managed to conduct.
Right.
Along with testing technologies like the computer-controlled reentry.
Yeah.
All of these were really critical in paving the way for Apollo.
It does sound like a mission that really delivered, doesn't it?
It does.
Achieved everything they wanted it to and more. And for you, the listener, we hope this deep dive has given you a really good understanding of this mission, saved you the time and effort of trawling through loads of different sources.
I hope so, yes.
I think it prompts an interesting thought, doesn't it? When you think about how ambitious Gemini 11 was.
It does.
And those what-ifs surrounding Gemini large Earth orbit, you can't help but wonder what other avenues in those early days of space exploration might have led to.
It's very tempting to speculate, yes.
If they'd pursued them. I mean, perhaps that's something for you to think about, listener. How might that mix of ambition and those big decisions, how might they have shaped the future of space history?
Indeed. Food for thought.
Until the next time.